So the synthetic substitution that you guys learned a while back to evaluate functions, you can use that same idea for dividing polynomials. So you can't divide every single polynomial using synthetic division, but if you are dividing by a linear polynomial with coefficient 1, you can use this synthetic division. So that just means that you have to divide by a polynomial with 1x plus or minus a number. So it can't be like 3x plus 8 or x squared minus 4. It has to be 1x plus or minus some value. So back when we did example number 1 here, because we were dividing by x minus 2, we could have done this using synthetic division. So that's what we're actually going to do now in your example. So that's where those coefficients are coming from, 1, 5, negative 7, and 2. We're dividing this polynomial by x minus 2. So when you guys used to set up for evaluating, it just gave you the x value. It said, hey, x is this, divide by this. So if we're dividing by the polynomial or the expression x minus 2, you guys have to know to set that equal to 0 and actually solve. So that's why we're dividing by 2, because x equals the value 2. That's what we're going to set up for our synthetic. So you guys know how to do the process, so get that going. So before, we would have just said, oh, the value f of x at x equals 2 equals 16. But now, all these place values have a placeholder, I guess, or a roll. So the last number is going to be your remainder when we do division. So this is your constant. That's a bad 7. Your x and your x squared. If you kept going, the next term would have been your x cubed, then x fourth, and so on. So if you guys had the problem written down, I did not, the answer when you guys divided those polynomials should have been x squared plus 7x plus 7 plus that remainder of 16 over x minus 2. So you can only divide polynomials using synthetic if you're dividing by 1x plus or minus something. If it's a squared, a cubed, something to the fourth, can't do it. And your lead coefficient has to be 1. So let's do one more. So remainder theorem, that's just saying, hey, this used to be what the function equaled. That's still the case, but when you're dividing, it's also just your remainder. So divide using synthetic division to x cubed plus x squared minus 8x plus 5. So we'll set it up. Again, if x plus 3 is your expression, set that equal to 0. X equals negative 3 for you guys to divide by. Coefficients, your x cubed is 2. X squared is 1. X is negative 8. Constant is 5. Bring down the first term, multiply and add. So again, last number is remainder. And if you start with an x cubed, guys, so start with an x cubed, every time you divide, it goes down 1 degree. So if you're unsure of like what these terms are supposed to be down at the bottom, I just work from the end, so I just know it's remainder constant x squared. But if you started with an x cubed whatever you end with is going to be an x squared. It's just 1 degree less. If you started up here with an x to the 5th, your first term would be x to the 4th. But we divided. Answer is 2x squared minus 5x plus 7. Why are my 7s looking so weird today? And then I know you could subtract, but I'm just going to add negative 16 over x plus 3 as your remainder. So these values now, these terms, just remember that they are spots within your polynomial. Now they're placeholders for your terms. But just make sure you solve for x. If you're given an expression, you got to actually get what x is to do the synthetic division with.